All right, I'm going to start making some videos on HSMWorks. I might be doing this ahead of our actual labs, but this represents 3 of our milling labs. This wax block. Okay. We will start out with a wax block. Looks like this. We're going to conversationally face the top and machine this shoulder all the way around it. Okay, and then we're going to G-code our way to the second shoulder. And then these last bits we're going to perform using HSMWorks. And that's what I'm going to be demonstrating today. I hope this video doesn't get too long. There's a lot of information here. We'll be covering a lot of this in class too. Okay, so the first thing you're going to do is click on Job, create a new job. I already have one started right here. And we'll take a look at what my goals here were. I wanted to represent where we were going to be starting with HSMWorks. So this is a milling operation. The model already loaded. We're going to use a fixed size box as opposed to relative or cylindrical or from solid or from extruded sketch. We're going to use a fixed size box, 1.75 in X and in Y, which represents where we leave off with our G code. Okay, our height Z is 1.5. I want them all centered. Okay, and our work coordinate system is use stock and orientation. This particular part, I drew it this way. This is exactly where our work coordinate system 0 is. So top center. Okay, I know we usually use a corner. We're going to use top center on this. So you're going to find an edge and find center of that in both X and Y. I called this wax block, and program comment top center of stock from bottom step, which is here. Okay, so that's my job. All right, now I need to create the first operation, which is going to be center drilling these 4 hole locations for a number 7 drill. You're going to go up here and click on drilling. I have to go through job, new operation, drilling, and drill because my computer is jacked up. I don't know. Library, I created these tools. Here's how you're going to create these tools. You are going to go by type. Okay, any, all these. We're going to scroll down to spot drill. There's one. And this happens to be a 118-degree quarter-inch spot drill. So let's find a quarter-inch spot. There's a whole bunch of them. They're all 90 degrees. Doesn't matter. We'll grab right-click one of them and copy them. And then I created a new library called 3160 Labs, and I pasted it in here. Okay, so here it is right here. I called this my tool 53. So let's take a look at what I changed. Okay, this is my tool 53. I selected manual tool change. I disabled coolant. It happens to be a high-speed steel tool, and in description I put quarter-inch spot drill. Okay, my cutter by default when I copied it was 90. I changed that to 118 degrees. That's really about the only thing that I changed. It is a spot drill. I didn't really worry about any of this information here because it's a spot drill. We're not using this to drill a hole. We're literally going to use this much of it. Okay, so the distance between here is really irrelevant for what we use this for. Shaft holder geometry, don't care. Feeds and speeds, on D2L I have this information for you. This is the same information that's posted in the lab. I use this, cutting speed times 4 divided by the diameter, and when I did that, I got 8,000 RPM. Okay, 2 flutes. We're going feed per tooth at 2,000th in both feed rate and vertical feed rate, and we're going clockwise. I'm going to go OK, and I'm going to select that bad boy. All right, now I've got a bit. Now what am I going to select? Well, I'm going to select face 1. Now because it's a hole, I can check this box and it'll select all 4. I only have to select one hole, select that box, and all of them will be selected. So if I had a plate with 150 holes, I select one, I check that box, it'll go to all of them. Okay. All right, here we go. Heights. I don't trust any of you, so we want a 2-inch from retract height, stock top 1 inch, from top we'll go 400 thousandths. Okay, and then here from bottom of hole, I'm going to put a negative 0.05, but not from hole bottom, from model top. I want to go down negative 50 thousandths from the model top. Okay, so let's take a look. Well, let's go here. And we're not going to be changing anything here. It's not deep enough to worry about chip breaking or anything, so we're just going to do a wrap it out and hit OK. Now let's run it. So it's selected here. We'll do a stock simulation. We'll zoom in, kind of get the right angle to see it. There it is. That right there is our spot drill for our number 7 drill bit, which is our next operation. I have a cat that needs to go outside. I'll be right back. Okay, hopefully cat's satisfied. Let's do another cycle. Let's get our number 7 drill done. So I'm going to I have to go to job, new operation, drilling, drill. Okay. I have this already set in my library. You would go to by type, okay, drill, find something. I don't know what the library has, but if you just go to drill, you can create the parameters. This is a number 7, which is a 201 thousandths, okay, which is a 0.201. I'm going to just use the bit that I created for this. Where is it? It is right there. I'm using tool number 54. So let's go into edit and take a look. I said 5,000 RPM, 2 flutes, and I skipped it. Let's go back to the Generals tab. I said this is number 54, manual tool change, coolant's disabled, it's high-speed steel. Description, it's a number 7 screw machine drill, and in comment, I made sure I put in that it's only an 1 3/16 length. It's a stubby drill. I wouldn't want to use this for a 2-inch deep hole, or horrible things would happen. Okay. In my cutter, tip angle is 118 degrees. My diameter is 201 thousandths, and I believe that I used some of the geometry that I have here. This is the bit that I ordered. It's an 1 3/16 long, 2 1/4 overall. Did I modify that? Yeah, I did. I put some stuff in here, so maybe it would show me if we had an interference. Okay. Shaft, holder geometry, we're not messing with. Feeds and speeds. Again, I said 5,000 RPM, 2 flutes. Because this is a drill, we don't have, this is all grayed out. We did 2,000 feet per revolution, clockwise. Okay. And I am going to select that guy. Alright, not going to mess with any of this. Okay, and then holes, again, I'm going to select this face. So it's going to make me select all of them. Okay, saving me a little bit of time. Again, I don't trust you, so 2 inches, 1 inch from stock top, and we'll go 400 thousandths from feed height. That's where it starts feeding in, so it'll go kind of slow. Okay. Here I am going to go from hole bottom, and I am going to go negative, we'll say 100 thousandths, okay, because the bottom of the bit has the angle on it. We want our actual hole to be final depth. Okay, I don't have the bit here, so I can't measure it. There's a function that I could have figured out. For right now, I'm just putting negative 100 thousandths. It'll be fine for this. Okay, this is an actual drill cycle though, so we're not going to just drill and wrap it out. We're going to do chip breaking partial retract. Okay, and my Peck depth, I want 100 thousandths for Peck. My minimum, 100 thousandths. Okay, my chip break, 100 thousandths, and dwell speed, we'll put 0.5 seconds here. Okay, let's take a look at that. So I've got my drill 4 here. Yours would probably be 2. Actually, yours could be 7. Each one of these is based on the number of times you did it. I've tried a bunch of different things, so let's simulate this. Hit OK. speed up a little here. There's our pecking cycle is happening. I've got it at the right speed so you can see that. 100 thousandths each. And 4 of them. All right. Okay. 2 of them done. Okay, let's keep going. I'm going to right click on job, new operation. We're going to do 2D milling and a pocket. We're going to machine this area here. I'm going to pick my tool. You're going to have to cruise around and create a tool. It's a 3/8 3 flute end mill. I called it my tool 55. We'll take a look at the bit parameters here. Tool 55, manual tool change, coolant's disabled. This happens to be carbide, and 3/8 inch flat end mill. Comment, I put 3 flute. The cutter, 375 thousandths flat. Okay. Shaft holder geometry, we don't care in this. Feeds and speeds. Said 5,500 RPM, 3 flutes. Okay. Feed per tooth of 2.5 thousandths. Feed per revolution, 2.5 thousandths. Clockwise. I'm going to select it. Excuse me. Okay, we're not going to mess with any of this. And I'm going to select bottom face. Okay. Easy. Again, none of you are trustworthy until this is, well, nobody's trustworthy until this has been proofed. Okay. We can go back in, once we know that this works, we can go back in and change these heights so that it's closer and work on minimizing our machining time. But for right now, we're trying to prove this, okay? You want to make sure that everything works without crashing the tool. Okay, let's look at passes here. I want a finishing pass, and we'll just leave that there, 0.0375 inches. I want multiple depths, and I want my depth here at 100 thousandths. Okay, and I want finish only at final depth. When I have one finishing pass, we're going to leave 0.0375 inches. It's going to do multiple depths, 100 thousandths per pass, and leave that until the last pass. We're not going to do any stock to leave or any of this other operation. And then here, let's see, we're not changing anything here. We're going to keep the tool down. Our lead in looks good. Sometimes there can be a problem on this helix depending on the diameter of your bit and the size of the hole. There might not be enough room to helix. We should be good with this. Let's take a look at what we got. It's calculating. It looks good. So I've got my 2D pocket highlighted. Let's hit stock simulation. Hit play. Comes down. First pass, helix down. Second pass, 200 thousandths. Helix down. Third pass, 300 thousandths. 400 thousandths. Looks like we have a 500 thousandths deep hole, and that final pass, it's taken off, so we should have good surface finish there. Great. So far, looks like our machining time is 49 seconds for that particular operation. Let's see where we're at overall. Select job. Hit go. And I can make this happen really fast. We are at 2 minutes 24 seconds. Here are the operations so far in these colors, so you can see that that pocket took more time, took just as much time as the other two operations. All right, another one done. Okay, we're going to work on putting the chamfer here on these holes, and then we'll go ahead and do the profile cut. So I'm going to right click on job, new operation, do a drill, Okay, I'm gonna pick, where is it? Oh, it's in here. I'm gonna use a half-inch 90-degree spot just to put a chamfer on it. I'm at 4,000 RPM, 2 flutes, 2.5 thousandths clockwise. Okay, I'm gonna select, and then I'm just gonna select that face and select everything. So check that box, it'll hit all 4. Okay, there's really not much else going on here besides our safe distances that we're gonna keep up pretty high for now. Okay, and drilling wrap it out, and let's take a look. Okay, let's slow it down. And finally, let's take a look at the whole thing. It's just, all right. Whoops. I like that. Stock simulate. Take a look at the time. We'll speed this up. Look at that, a little too far. What do we got for time now? 2 minutes 55 seconds. Okay. Okay, let's do our final tool path here. I'm going to do a new operation, 2D milling, 2D contour. Okay, the tool that I'm looking for is in my library. It's a 1/2 inch flat. I'm calling it my tool 52. Okay, it's a 1/2 inch flat Endmill, manual tool change disabled, carbide, coolant's disabled I should say, carbide material, 1/2 inch flat, cutter, 1/2 inch, it's flat Endmill, it's not particularly long, feeds and speeds, 4 flutes, 2.5 thousandths. I'm going to go ahead and select it. We're going to select this contour here. Okay. Safe retract height, safe stock height, safe retractor from top height. And here we're going to do, where is it? Multiple depths of 100 thousandths. And that all looks good. Let's take a look. All right, so it calculated it. Let's simulate it. We'll slow that down a little bit. We're leading in, coming around. Good to go. Worked good on wax anyway. Let's take a look at that. Oh, looks good. Let's hope it goes this well in lab. All right, so myself and Oswald the cat are done with HSMWorks for the day.